Good job. Okay, so this is multiplication and division of numbers that are positive and negative. And so the reason I wrote it like this is because the rules for both of these are identical. So this is good. So once you get one, you've got the other. And so that part's the good news. So I'm going to start with 4 problems. And so I'm going to multiply this and this. And that's the one you know because you've done it for years. So a positive number times a positive number is still positive. Is that okay with you? So now let's take this multiplication problem. So 3 times negative 5. So I want you to think of it as if you spend $5 and you spent $5 and you spend it a third time, you've actually spent how much money? Well, it seems like the correct answer is 15, but what's the sign? Did your checkbook go up or did it go down?
Up.
When you spent $15?
Wasn't it 20?
It goes down.
It would go down. Okay.
Oh,
So-
negative. Yeah, that's what I.
Okay, I know that's what you meant. So 3 times negative 5 is negative 15. And it wouldn't matter if the 3 was the negative and the 5 was the positive. This you could assume is you had $3 and you spent it on coffee 5 times. But still, what's happened is you're still on the negative side. So what these two amount to, a positive times a negative in any order ends up being negative. So it's like 3 debits, 3 times I spent money. And so it's definitely a negative. Now, the interesting one is the last one. If you have a negative 3 multiplied by a negative 5, that's a strange one. What is it? Anybody know?
Positive?
It is positive. Let me let 2 people in. So a negative times a negative is a positive. Now, if you remember what we did on Wednesday about when we added 2 negatives, it just made it a bigger negative. But when you multiply, it ends up positive. And so somewhere along the line, we have to write down some rules until we've got this in our head and we don't need to look at a piece of paper. One way you could think of this is when you have 2 negatives. It was something I did the other Wednesday. The opposite of a negative, one negative opposite the other one negative, is a positive. And that's one way to rationalize how this turns out. But this is exactly it. So if it's 2 positives, it's positive. If it's 2 negatives, it's again positive. But if it's 1 and the order didn't matter, 1 negative and 1 positive, then your answer is negative. So the good part about this particular rule is that now I'm going to do division and I'm going to do it with like this. So if the 2 numbers being divided are both positive, the answer is positive like always. But because this is going to be identical to multiplication, when it's division and there's 1 negative and 1 positive, it's going to be negative. And it did not matter the order. If the first number was positive and the second was negative or vice versa, they're both negative. But the interesting one, of course, is the last one. A negative divided by a negative is a positive. So there's something I want to tell you about. If for some reason you ended up with this number, okay, and that was your final answer, this is considered bad form. And so mathematically, we don't leave it like that. What we would then do with an answer like that is one of two things. Either we bring the negative out front, or my preference is we put the negative in the numerator. Now, there are advantages to having it in this form when we do some of our computations. And so I prefer this to this. And I looked, at some of the problems, and sometimes this is a visual thing, and maybe your eyes are clearer than mine. But when I see the minus, the negative, and then the fraction line, and I'm real tired, I don't always see it very clearly. Do you know what I'm saying here? I tried to make it so it's sort of running into each other. So in that way, I prefer it visually here, so that then if it's negative, it's in my face, I see it straight about. This one is considered poor form. Whether they'll mark you wrong on your homework, I don't know, but probably they should discourage you from doing this because it's sort of like a faux pas. This is not considered a good way to write the final answer. So this one is acceptable, and this one, I prefer this one. You'll see why when we do a couple of problems, but I just wanted to mention that. So we've kind of got the rules down. And the interesting part about it is, let's try this problem here where there's three numbers, which is an extension of what we just did. So if we did this out in order, I would multiply this times this. So that's a negative times a negative. And so 2 times 3 is 6. So a negative times a negative is a positive 6. But I'm not done yet. I then had the -5. So this problem is a positive 6 multiplied by a -5. And so that would be, one negative would be negative. Now there's a shortcut way to do this, and it has to do with counting negatives in a multiplication or division problem. So if you have one negative and the rest were positive, it's going to be negative. When you had two negatives in your problem, it's going to be did I say that wrong? When it was one, I think I said it wrong. I'm not sure. Let me just change the problem. If the problem has one negative, it's going to be negative. That was my point. And I wasn't sure if I said it right. If I have two negatives, and that's the total number of negatives, it ends up being positive. But what I wanted to show you with this problem up here is when I had three negatives, it goes back to negative again. Now let's see why that's going to happen. When you have two negatives, that together makes a positive. So you're really just down to one negative, and one negative makes it negative. So one negative, negative, two negatives, positive. Do you see where this is going? Three negative, four negatives would be back to positive again. And so if you had a stupid problem like 17 negatives, okay, I give you this, -1 to the power 17, which I don't want to write out, but I'll tell you what, it's -1, -1, -1, 17 times. Well, the answer is a 1, but the question is it a positive 1 or is it a -1? And so if you're starting to see the pattern, when there was an odd number, it was negative. When there was an even number, they basically canceled each other out and it became positive. So three negatives, negative. And so because this is odd, we don't have this match for the two negatives to cancel each other out. And so this would end up being -1. I don't think that problem is in your book, but I thought there
There's
is
a
a
lot of
pattern to
problems with
this.
exponents though, so thank you.
Yeah,
Yeah, I got hung up on that. So thank you for writing that out. That was something that
okay,
was, yeah.
good, good. So, um, so that's the case. So I had some questions here. Let me see. The book writes it like this, and so I'm pulling out, and then it's multiplied by -15 over 28. Okay, so that's, once you can see it, that's the way it looks in the book. Well, frankly, I don't like my negative there. I like it on the top. And so if I had immediately written it, I would have done this. Because half of the problem will be getting the correct sign. In other words, you know how to crunch the numbers and get a correct number. So there's really two parts to these problems. So I look to see, did you get the right number? And secondly, did you get the right sign? And they're both equally important. So when I look at this problem, either from this version or this version, I see two negatives. So the two negatives are going to be positive, and so I'm done with that part. But what I do see is this is what we got used to, and this is our fractions again, heaven help us. 4 and 28, 4 into 4 once, 4 into 28, 7. And then the 5 and the 15, I'm ignoring the negative, divide by 5, 5 into 5, 1, into 15, 3. So the number part of this answer is 3 over 7. But the sign, I want to be, I want this, half of this is getting the sign right. Two negatives are positive. And so the simplest way to write a positive is just without any sign at all. That's assumed positive. So it is 3/7. And so that's it. Okay. So again, I don't go for that. And there'll come up some examples where I'll show you why. Let me try this one here. -4 multiplied to 5 multiplied to -6. This is similar to what I did a minute ago. It's three numbers. And so we have to get the number part and the sign part. Now I look very carefully because it's all multiplied, so it's under one rule. Counting negatives will do it for you. So the two negatives, that's going to be positive. So all I have to do is say, okay, right. 4 times 5 is 20. 20 times 6 is 120. And then I double check my work about the sign, negative times a negative, positive. Yep, I like it. Did you like it? Okay. Now you're going to, this drives people, well, I shouldn't say that. Let's do the next problem. Okay, this problem that I made up has parentheses. And the parentheses are defining the number that's getting repeated. So it's a -3. So this technically is -3 multiplied by -3. Okay? So 3 times 3, of course, is 9. And two negatives. Negative times a negative is a positive, so I leave it like that. Now, here's a problem that looks identical, and it's not. The difference, I've seen students, 4 courses down from here, still making this mistake. And so we need to look at it now and try to get this point here. The number that's repeated in this second problem is not -3 like this. It's just 3. So the number that's repeated is a 3 and another 3. Now, what about the negative? Well, either you put the negative out front, or in some cases, you actually imagine it to be -1. Either way, only the 3 is being squared. So 3 times 3 is clearly 9. But there's only one negative. The minus did not get squared, just the 3. And so one negative makes it negative. Now, if it helped you to imagine this negative as a -1 factor, then go for it. But no matter how you slice it, that's -9. These two problems create issues for students. Can you see it? So it has to do, the parentheses are so good because they tell you exactly what the base is, what the number that's being repeated. And so that's really good. But this one here, it's order of operation, to be honest with you. The squaring is done first. So 3 times 3 is 9. At that point, you apply the negative, and you can think of it as a -1 or just a negative. No matter how you slice it, it's -9. This will keep coming up, and I did see a few problems like that. I'll try to slip one in a little bit later in the class. Let me see what I got. Okay, here's our next one. This is where they've mixed things up. So the parentheses is telling you that you've got to do that first. And so if you recall, you've got to ignore the 7 for the moment. If you have a -6 and it's an addition problem and a +3, what is that? How much do you have left? I'm going to put it in parentheses when I get it. How much is there? Think about what would be left. I had -6.
3.
What kind of 3? So that's the big issue.
Negative.
It's -3 because the 6 was weighted more. It was bigger. And so we had more negative than we had positive. Therefore, we're still on the negative side. Do you remember the one way this was done? Well, you can do money. Remember, we talked money. 6 below, you were 6 in debt, and then you paid back 3. You still owe 3, or something like that. But these two go together. That was Wednesday. Then this is today. This is multiplication. Clearly, there is one negative, and therefore a positive times a negative will be a negative, and the number, of course, is 21. How is that?
Good.
Let me try a different one. Similar, -3 plus 2, 5 minus 3. Okay? Same deal. Parentheses is first. 5 take away 3, that's not an issue. That's 2. Here's 2. There's a -3 here. Remember, this adding is last. I've got to do the multiplication next. Fortunately, this is a good one. 2 times 2 positive is 4 positive. I've got a -3 out front. Now the rule of addition is, what is our final answer?
1.
It is 1, and it's positive, isn't it? Because in this case, the 4 was the bigger one. We had opposite signs, so we're technically subtracting the two absolute values, if you want to know the truth. And 4 take away 3 is 1, but the sign goes to the larger one, and so it's positive. So we're definitely on the positive side. Let me see. Okay, I'm just pulling some problems out. So here's the next one. 3, -2, 4, and then 3 times -2. And you'd probably like to see it. Adding is last. So what I have at the front here are 3 numbers. 2 of them are positive. I can ignore that. There's just 1 negative. So whatever I get out of this, it's going to be negative. So I quickly do the number part. 3 times 2 is 6. 6 times 4, 24, if I'm still thinking correctly. This one here, this is multiplication. This, of course, is last. 6 times -2 is -6. I might put that in parentheses just so that I don't have that strange double sign there. And so it's adding. So I've got, this is a bad situation. You borrowed $24 and then you borrowed 6 more, darn it. Where are you?
-30.
-30 it is. Okay. So my advice is just go slowly with this and see if you can't make this work. I have one more that looks a little bit worse. -3 times 4 minus 7, subtract 2 times -3 minus 2. Okay, that looks a little bit worse to me, but we can do it. This subtract is last. This problem is in 2 parts. This is the front part minus, this is the second part, because this times this is multiply, this times this is multiply. And so that's how I'm seeing this problem. Half the time it's about seeing what you have. So the first part, I'm going to deal with this. 4, subtract 7. Now, if I only had $4 and I spent 7, I'm in the hole. How much?
3.
3. So this is a -3. Is that clear? I had 4. I took away 7, even though it didn't, wasn't too fancy. That's clearly -3. I had a -3 out front. Then I have subtract 2, and I'm going to put these 2 together. I had a -3, and then to top it off, I have a -2 more.
5.
What kind of 5?
Negative.
Okay. This is still last. I'm going to do this and this. This is multiply. A negative times a negative. 3 times 3 is 9. Negative times negative is positive. Okay. Now, this is why I offered this problem. Technically, there's 2 negatives here. I'm going to try one approach, and you may not like it, and then I'll try another one. I'm going to keep the negative. I'm going to multiply these 2. This is 2 times -5. So I'm saving the negative sign for last. 2 times -5. Well, a positive times a negative is a -10. But I've got that funny thing, a negative thing, which I don't like. So I'm going to put this in parentheses, the 2 times -5. We're almost home. This subtract a negative. Some people learned it to just say, oh, I know what that is. That's a positive. If you learned it that way, that will work perfectly well. The other way I explained is that when it's subtract, the first number is copied, the subtract sign goes to add, and the second number goes to its opposite sign. So -10 becomes +10. That's the same thing as calling that positive. So the answer is 9 plus 10 is 19. So I just wanted to show you one. Yeah.
Ms. Patterson, how did you know? We're gonna go to the first one, the second, -2 times -3, -2, the very first one. How did you
Right
know?
here in distribute?
Yeah. How do you know to subtract, but you didn't subtract the 2 and the 5? You multiply it.
Okay, so it is possible, there's multiple ways to do this, to distribute a -2. And I think at one point in time, you might do that. In general, not always, but in general, following order of operation gets you there quicker. So inside the
Oh.
parentheses, ignoring anything else, is a -3 and a -2, which is a
A
-5.
negative.
That's still in parentheses. The parentheses did not go away, right? The parentheses did not go away. And so the
Okay.
parentheses is basically telling us multiply.
Oh,
There's no sign here. There's nothing to say like add or, whatever. There's nothing. And
Yeah.
nothing, and the use of parentheses is an indication of multiply.
But wouldn't the negative times a negative equal a positive?
Yes. And eventually you'll start to say, well, I know what this -2 is. Or subtract 2. It's really adding a -2. So it's like -2 times -5 is +10. And so you sort of like went quicker. And I showed this step partly because sometimes people need to take more steps as they're learning this.
Mm.
But as soon as you see this, a -2 times a -5 is a +10. There's no way, there's no reason to not go straight to that step.
Yeah, but I would have read that problem completely differently.
Okay.
I think for me is I read the subtraction sign as like in a word sentence, it could be like a comma or an and, because if it wasn't there, it would be a run-on sentence.
Oh yeah, that's exactly it. This actually pays off in algebra when you see the sign that separates. What I was trying to do is encourage you to see this as two pieces, because this is treated as one number, and so it's multiply, multiply. This is one number, this is multiply, multiply, and so this is where, this is where it breaks mathematically. So run-on sentence, you can go with that. In algebra, we'll call these separate terms, and we'll probably throw a few X's in there just for fun, but that's where the break is. And remember that the subtraction is dead last unless it's inside parentheses, which forces you to do it first. The parentheses basically is an exception to the rule, right? Well, that was the hard one. So let me see. So let's do a little review. -17 plus 5. So I want you to just write something down on your paper, and then we'll talk about it. Let me do another one. Are you ready?
Done. Gotta write it.
Did you want a second?
Yes.
Put down what you think. This is like
Okay.
a little practice thing. Yeah. Okay. All right. Who wants to tell me -17 plus 5?
-12.
-12. This is addition. And there's more negative there than positive, so we're at -12. Somebody tell me what the second one is.
-18.
-18. So it's a negative and then more negative, which makes it even more. Okay. Now we're into two subtract problems. You can do it any way you like. Just get it right. Who wants to tell me?
15.
You
got
want it to be 15?
I
How
got
did you do it?
6.
It is 15. How did you come to it?
I made the negative next to the 9 positive.
Okay, and then what did you do here?
Then I added, right?
Okay, so if you kept the 9 and then you made this, is that what you said?
Yeah.
Plus, and then you've got to turn this into its opposite, which
Yeah.
is the opposite of negative would be plus. That's the simple version of this problem. And the answer then is, I assume that's what you said, 15?
Yeah.
Yeah, okay. Who wants to tackle the last one? Fortunately,
Is it negative 17?
almost. This subtracting a negative. What?
Positive
Is it
7.
a -3?
A -3.
Yes, it is. Very nice. So here's one approach. The two
Oh.
negatives become positive, and so it's actually -10 plus 7. That is -3. That makes
I'm still
me think.
confused
Yeah,
that
go ahead.
I'm sorry. So I'm still confused that the two negative signs seems like we're interchangeably calling the first sign minus.
Well, I guess I talked about on Wednesday saying you can say minus. Technically, it's subtract.
Also, yeah.
Subtracting a negative, but another way to see it is the opposite of a negative. That will do it for
Okay.
you too. And the opposite, and this is one interpretation of this sign, the opposite of a negative is a positive.
Right, right. It's just that I think if I'm gonna call it a negative sign or minus sign, that's two different things.
I'm with him on this. I'm just as confused.
Well, do you want to say minus? Did you learn to say minus? See, this is
Well, I mean,
when you were in school, if they said minus,
yes.
see, I've taught for a long time. And so then they said, oh, don't say minus, say negative, right? And so, but it's a minus minus if you want to, a minus times a minus is a plus. If that
Yeah.
works for you. So
Well,
I
I understand
more
that.
recent use of the language, but it doesn't matter.
Okay.
If that's
Just have
okay.
to make
Are you
sure.
happy? Do
Yeah, I
have
just have to
happy?
make sure of what they want us to do here. So yeah, that's good.
As long as you know it. Okay. I just thought of another problem when I did that. So
Great.
oh, tell me what you think this is.
Positive 5.
Maybe.
Maybe.
Is it negative 19?
That's a no, by the way.
I think that's gonna be
Negative 19.
Negative
it's a
19.
-19.
Does anybody else want to contribute an answer to this?
No, but I'd like to know how.
Okay, I'm going to give you several approaches. Okay. These signs backed up
Okay.
to each other.
Oh, that's right.
You can treat this as subtract, and then you can play my game of this goes to add and this goes to its opposite. That may not be the easiest to do, but that will work. Another approach, I'm going to try this for a little bit. It's like a negative times a positive will end up being negative. So this actually is -12, -7. And your answer is?
19.
Negative 19.
That is.
That makes sense.
Oh, right.
Let me walk you through the other approach. When I see this as subtract, one rule that will always work for you, and so this is, I'm not saying this is the best rule, I'm just saying you can count on it, is you copy the first number, subtract goes to add, and the second number goes to its opposite sign. So this is the rule: subtract, change to add, and change the second number to its opposite sign. I think what happens is people learn it and then they see patterns, and once they see the patterns, they take shortcuts and they still get it right. So for instance, this pattern here, subtracting a negative or minus a minus, or however you want to say it, is plus every time, right?
Right.
And so I'm not saying this is the only way to do it. I'm just saying this is your backup method. So the first number never changed. Subtract went to add, and the second number went to its opposite. Then it's an addition problem. And for most people, addition is simpler to comprehend and to make good choices. Negative 12 and another negative 7 is clearly negative 19.
So
How's that?
if it was negative 12 plus negative 7,
That's what it, oh, I thought it was that. Well, maybe it wasn't. Negative 12 plus negative 7 to begin with?
oh, then you flip them, right?
Well, no, there's no flipping at all. Addition
there-
is
Oh, it could be
wonderful.
a positive, right?
Oh, wait a minute, we're swimming around here. This is addition.
Yeah.
We're back to our checkbook. I can't
Oh.
make positive out of this
Yeah.
transaction.
Yeah.
Can you?
No.
No, you're in the hole.
Yeah, now
How
I
much?
got negative 19. Got
So
it. I know it's
this is
just,
why seeing what the actual operation is, that this is addition, makes all the difference in the world, because when it's addition, it's back to your checkbook, or if you're thinking temperature, that'll work too.
okay, if it was subtraction,
Okay, now we're in different territory.
yeah, that's what I
Subtract
think. I was,
what?
huh? Negative, positive 7, wouldn't it be?
You can do that. Let's do that one.
So that would be negative 5? No, because it's,
That didn't work. So we're gonna have to get you something that's gonna work until you've got this settled.
yeah,
Let's think about this. And this may or may not have had parentheses.
oh, I didn't change it, did I? Positive and
Yeah, I
negative.
mean, this is
Yeah,
the same problem with or without parentheses.
yeah, I have to remember the negative and the positive.
So if you wanted to follow the rule, and it doesn't seem to be most people's first choice, but it will get you the right answer. And so that's got to be worth something. If you followed the rule of switching, subtract would go to add.
Yeah,
The second number would go to its opposite sign. And once it's addition, I think you'll get it right.
okay. That
So you
makes
may
sense.
need to do
Yeah,
that for a while until everything becomes clearer. This one, somebody might have said, well, wait a minute, I'm at negative 12 and then I'm going to take away another 7. Things are not getting better, are they? They're going down. And so clearly, and another version of this would have been without the parentheses. Would that have been better?
yeah,
Negative 12, and then you have another negative 7, or subtracting 7 more?
If the
You're not
7
ending
is
up
in,
better, then you're gonna get worse, right?
yeah.
Wouldn't the 7 be positive if it's in parentheses though?
Yes. And so if you go with that approach, it would be positive, which means it's still subtract. The first number is copied. The subtract becomes add, but in parentheses, the positive 7 becomes negative 7.
Right. Got that.
So the subtraction rule may be useful to you for a while, until you start feeling more comfortable with this. And you might always use it for that matter. But in the end, I think sometimes you see shortcuts and or the problem looks a little different. But do you need to make a fuss about this problem? What happened to your checkbook?
It turned into a +2.
Did it? Can you make positive out of these two subtractions?
Or -30, -35.
Well, you're trying to multiply them, but it's not
Negative
multiplied.
12.
Negative 3.
That's, we finally got it, yeah.
I just think checkbook. That's all.
Big checkbook.
That's the only way I
If
can
you
do it.
lost 5 and then you lost 7, oh, what?
Yeah.
That's where you are. And so in a sense, a lot of these will make sense unless there's so many negatives, you have to sort of like simplify it before you begin.
But you know, the ruler helps too, to glance
The
at.
number line, yeah. I think
And
it
if I keep
helps.
this next to me,
Okay.
just to kind of help me get through it.
So what I wanted to show you, let me see if I can find a good one. Oh, I'll have to make it up. -3 over 10 times -20 over 6. Okay? Because multiplication and division go with the same rules, you can still count negatives. So the two negatives in this problem will be, the answer will be positive. The only job for you is to come up with a number part of it. And so I made this so that the 3 and the 6, 3 goes into 3 once and into 6 twice. And then I made this real simple. 10 goes into 10 1 and into 20 twice. Oh, well, I made it simpler than I expected. 2 divided by 2, I could reduce that even further. So the answer is 1. 1 times 1 is 1. 1 times 1 is 1. Positive or negative?
Positive.
Positive. So in this particular section, I'm going to count the sign as important as the number, because this is really about signs. It's like, can you get your sign right? And so that should work. I saw one more. Well, maybe what I should do is, were there problems from the homework that somebody's written down that we could do? Is there anything? In some ways, we reviewed all the sections in chapter 10, but there still may be some sticking points here and there. Did anybody have anything? I just found a beauty for you.
Right.
I had one.
Go ahead.
And I think now what we learned today is why I was getting it wrong. It was
Okay.
-2 over 5
Okay.
plus -1 over 5 plus 3 over 5
Is that it?
plus 3 over 5.
Oh. Well, if I had seen the problem, I would have probably written it vertically. But the truth of the matter is, it's a pretty good problem because it already has a common denominator 5. So that part's good. So the adding, I've got to add this and this and this. So I've got to add a -2 and a -1 and a +3. And so the 5 just carries over, but the numerators, the top numbers, have to be added. So let's just take them as they come. This is addition. A -2 and a -1.
Is it
How much?
+3?
No, -3.
It's -3.
How's it?
See, this is
okay,
addition,
flip
this
them.
is money. Money.
Flip.
So this is
Flip.
-3. Then this is +3. And how much is that?
0.
0.
Now, this is your
Yeah.
this is the first round of this problem. But remember, the simplest version, this is not it. What is the simplest version of this?
It's undefined.
No. Remember,
Isn't it?
undefined was this
Okay.
with the 0 on the bottom.
Is it negative?
If you have nothing and divide it into 5 equal pieces, what do you have?
Nothing.
Nothing.
Well, yeah.
So it's just 0.
But I answered 0 and I answered 0/5 and both were wrong.
Really?
I thought that. I thought
Well,
the answer to
that,
one was undefined.
this one should have made it. This one they probably wouldn't accept because it's not simplified. If you want me to look at it, send me a message or
Okay,
something and I'll look at it. But that is the correct answer.
okay,
0.
because that's what I got. And then when it kept telling me I was wrong, I was just completely stumped.
No, because I mean, there's absolutely no, this has to be 5.
Mhm.
And if this was all addition, and so what I would do, with this problem, is make sure that was a plus and that was a plus. That's the only thing I could suspect that could have gone wrong, or then any number could have been copied. Notice how I brought my negative up? So that way I can see it more clearly. Do you see that
Yeah.
it makes it easier? It's a visual thing. But
Yeah.
doggone, when you're into all this positive, negative stuff, you want to be able to clearly see what you're working with. And so that's why I like it up front on the top. And you don't have to do it, but I recommend it. And I have no idea, but send me that problem and I'll look at
Okay.
yours and try to figure out what they were thinking. Okay. Anybody have anything else? Okay, I found this one.
No.
Did you have one? Did you have one? Who was it? I'll be glad to
No,
do
that's
it.
good.
Yeah, go ahead.
Oh, no, I don't.
Oh, you don't? Okay. So here's one. This is multiplication and division in the same problem. Who cares? They use the same rules. The next thing I notice is negative. It's all multiply and divide. So I don't have to, use the add and subtract rules at all. So I can just count negatives. 3 negatives will make this problem negative. Now, you can do it piecemeal and do these 2 first, and that gives you positive, and then divide by this, and that would give you negative. The truth is 1, 2, 3 negatives will make the answer negative. And I'm going to cancel the 6 into the 12 just because it's there. So a 4 times a 2 is an 8 over 1. I'm just going to say 8. But the sign is determined by how many negatives I have in a problem that's completely multiply and divide. And so I can't, I can get away with that in this particular problem because every single thing is multiply or divide. And so they're all into the how many negatives that made it, 2 negatives made it positive, 1 more made it negative again. And there you
Yeah,
go. Mhm. How do you like it?
love it.
You love
Can you
it.
show another way to?
You want
another way
another
to-
one like what?
Well, not the same problem, but another way to do it.
Okay, I'll get you another way.
Yeah, thank you.
So a -4 times a -12 over a -6. Now, I really wanted to cancel, but I mean, technically, I could have done this first.
Hmm.
And a -4, -12 multiplied would be +48. Positive. Over -6. So a positive divided by a negative will definitely be negative. But
Yeah,
the canceling in the problem makes it easier, but I could still do it. 6 into 48 happens to be 8. Did you like that better?
yes.
no.
Okay. See, this is the thing. If your method works all the time, and I don't mean most of the time, then there's nothing wrong with doing it if you're comfortable with it. But there are certain problems that don't work. It works one way and then another problem comes up and it doesn't work. Then you
Right.
need to make a change. You need to change into something that's working all the time.
See,
Okay.
I did it the long division.
You did long division?
Yes.
Well, I mean,
The only
really.
way I did, yeah, 6 into 48, and then it was 7. Well, no, then
No,
it
it's not 7, because if you used 7, you would have been out of luck. I'll show you.
no.
When you
And then
use
7
7,
times 6 is 42.
when you subtract,
So 6 is 1.
no, no.
Oh
When
my
you
God.
subtract and it's as big or bigger than this, you've made a mistake. You needed to go one higher. Plus, you should know 6 times 8 is 48.
Yeah.
But forget that. When you subtract, and this subtraction is the same size as the divisor or even bigger, you didn't go high enough.
But I did. I went 6 in the 48 is 7, 42, 6. And then I went 6 over 6 is 1. And I
Oh my gosh, you're really,
see what I'm saying? That's how my mind works.
oh, well, that's not gonna do it.
But it'll
super
still
long.
do it. I mean, I still got the answer.
I know, but see, that's going the slow route to,
I
slow
know.
road to, I don't know
I'm
where.
slow.
No, I don't mean that. I mean, you're doing 4 extra steps.
But
I
that's
could
the only
take
way I
any
can
problem and do
understand
100
it.
steps.
Okay, do it the fast way again.
Well, the fast way was this first way,
Okay.
where I canceled because it was all multiply and divide, and I could see that from the beginning. I canceled the 6 and the 12.
Yeah.
4 times 2 is 8, over 1 is 8. But then I tried to figure out the sign. And 1, 2, 3 negatives make it negative.
So it'd be negative, negative is positive, and negative
And
is
1 more negative makes it
Yeah.
negative again. So it goes back and forth. 1 negative is negative, 2 is positive,
I
3
don't
is
know. I don't.
negative, back
Yeah,
and
that
forth.
makes sense. I know mine sounds crazy, doesn't it? Hey, I still
No,
got
it
the
just-
answer though. That's the problem.
I've seen every kind of strange thing, and I'm always amazed when somebody has something new. So new is good, but on the other hand,
It takes
things that make it more likely you're going to make a mistake.
It's called overthinking.
Oh, is it? Okay.
That's
Is that what we're going to call it? Overthinking?
Yeah.
Okay. Well, call it what you want, but I don't think you want to do it.
I just think that new is scary.
What was that?
New is scary.
New.
Yeah. Yeah, it sure is.
Well, once in
Yeah.
a while I see something cute. But it
What?
actually boiled down to this, and this is the rule. When you subtract, this number should be smaller than the divisor. That's it. And when it's not, this is not smaller, this was a mistake. That was where, so I wouldn't recommend doing what you did. But see, this was saying, nope, 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 wrong number, wrong. Right when you saw the 6, that's where you should have said, wait a minute,
Yeah.
wait a minute.
That's where, see,
That's where it, that's,
I have to
that was
train
my
my mind to
signal
do it. The other
that
way.
I guessed wrong. That was the signal. I guessed wrong. I didn't guess high enough. What do you think? Is that enough for good?
Mhm.
Okay, so we'll do what we normally do. I'm going to stop